My name is Shannon Williams. I'm with Citrix. I am one of the original members of Cloud.com team that Citrix acquired earlier this year. So I'll be talking a little bit about Cloud.com and CloudStack and the Citrix Cloud platform stuff. But I wanted to start because this is a bit of a technical conversation by just getting a little bit of information about the audience so we can kind of determine how deep to go and how deep not to go. So maybe start with this. We're going to be talking today about building infrastructure clouds, setting up and deploying hypervisors, storage, networking, things like this. How many people here would like to mostly focus on the business side and what it would take to build a cloud? Any hands? Good. And how many people want to focus on the technical side? Who wants to kind of go deeper, talk about different hypervisors, different storage architectures, networking and such? Okay, great. So we've got the right level of awareness. Come on up. There's plenty of seats in the front. Cloud.com was a startup. It was started in 2008, and it developed the CloudStack product, which is a infrastructure as a service orchestration product. And the company was really, it started literally 5 guys in a garage kind of story just up here in Cupertino. But we really were inspired by Amazon. I mean, as we were a bunch of serial entrepreneurs, we were very much engaged with starting companies and dealing with the challenges that you had when you built new ideas in getting infrastructure. And when Amazon came out in 2006, we were, it was just amazing what a difference it meant to the ability to execute on your ideas, the ability to get infrastructure quickly, to scale up when you started to see demand. And it became very obvious that this was going to change computing pretty heavily. We were going to see a shift and a much different architectures, not just in terms of going to colo providers instead of cloud providers, but also in the way that enterprises deploy clouds. So maybe just kind of show of hands here. How many people here are interested in building a private cloud? Okay. And how many people are interested in building a business like a public cloud business where they want to host a cloud and sell those services? Okay, a little bit of both. So we'll talk about both today. And so Cloud.com, again, started as a little company in 2008. We were acquired this summer. We had about 80 people, about 100 customers around the world. And the focus as a company was really on helping people deploy and build infrastructure computing clouds. And that meant we worked with a lot of service providers. In the beginning, as we got off the ground, there was just an enormous demand of people who wanted to transition existing managed services businesses, existing co-location businesses, hosting businesses into cloud businesses. And that really kind of fed our growth. So companies like GoDaddy and Korea Telecom and Tata and British Telecom and all these companies began building clouds on CloudStack back in 2008, 2009, and 2010. It was only later that we started to see enterprise, begin to look at this type of platform and decide they were going to implement their own private cloud on this infrastructure. And that's probably not surprising. If you think about it, the pressure on a service provider or anybody who was building a hosting business in 2009 because of Amazon was pretty intense. I mean, Amazon was growing at something like 600% year over year. And there was just massive demand. And if you were in the traditional business of selling dedicated servers, that's a pretty intimidating situation. And so with time, we've definitely seen that the sort of intrigue and interest from large companies, enterprises, Web 2.0 companies in what a private cloud might be able to do for them has very much matured and has become something a lot more real. And we've been, today the biggest CloudStack deployment is a 20,000 server deployment that's being used with RightScale on top of it at Zynga. So we see really large private cloud deployments now, even outpacing some of the bigger public clouds. So, but if you think about where, what is CloudStack exactly in a little more detail, CloudStack's an orchestration layer. It's a piece of technology that sits on top of the hypervisors, the storage, the networking, the compute to make all this possible. And one of the reasons that Citrix acquired us and has really been very bullish about this is that Citrix has a big history of powering computing clouds, but they were always sort of down at this level. They provided the Zen hypervisor that's used by Amazon and RightScale and others. They provided NetScalers, which do most of the load balancing for big cloud providers. But the reality is when it's time to build a cloud, those individual pieces are only part of the work. You can buy your storage, you can deploy your servers, but at some point you have to choose an orchestration technology that's going to take all those things and automate the delivery of them, across hundreds or thousands of servers, which might be running in data centers all over the world. And that's what the orchestration layer, an orchestration layer like CloudStack does. So we're going to talk a lot about that and about how you orchestrate these things. But what's really important in the end is that, at the end of the day, all this is giving you is a UI and an API to automatically provision a virtual machine with some networking, storage, compute, maybe a firewall, a load balancer, some network devices, things like this. It's not about the applications. And this is where, one of the reasons that, Cloud.com and Citrix have worked really closely with RightScale is because for our customers, when, once they implement this infrastructure as a service, there's an obvious sort of pause and then a now what kind of moment as they realize that, they want that Amazon-like experience that they've been talking about. They want auto scaling. They want images to be provisioned quickly and then span across 15, 20 different servers in a matter of minutes. And that is all done by RightScale. And it's one of the reasons we're here, and it's certainly as big a fan as you're going to find of what they do. They make all this stuff possible. But there's other things out there too. I mean, we see people now deploying platform as a service on top of this. We see people that are building their SaaS directly on top of the APIs for things like CloudStack. There's certainly the beginnings of a shift on the desktop side where people are building desktops as a service. So when you talk to anybody today and they tell you they do cloud, it's not surprising. I mean, this list is littered with anybody you talk to about technology. The reality is it's pretty important to try and drill down on that and understand what value are they providing, what are they doing in that space, and why would it be a good company for you to work with. But if you look at one of these, I always like to kind of start with an example of an infrastructure as a service cloud just to kind of say, what are you trying to get to? And Tata's been an early RightScale and CloudStack customer. They launched a cloud called InstaCompute in 2010 at the beginning of the year, and it's a pretty good sized cloud. It's running in UK, Singapore, Hyderabad. It's got hundreds of servers running it with probably about 2,000 customers running on it. So medium-sized infrastructure as a service deployment. And the great thing about this is it's a good example of you can experience this stuff today with just with a credit card and a sign-up sheet. I mean, you go to infrastructureasaservice.tatacommunications.com. Click on the Try Now button. You pick through some different options for kind of creating an account. Do you want to sign up with a credit card? Do you want to set up a trial account or a corporate account? Log into your account, get validated, and within a matter of minutes, you're into a web portal with access to an API where you can start to upload your team members, put them into projects, allocate budgets, define how much they're going to be able to use, and then very quickly drill into these projects, pick the project that you're working on, and have access to that virtual infrastructure, all the virtual machines you've created, the storage, the networking, the compute. You can upload your images, you can download your disks, you can go in and set up automated snapshots. And these are the kind of things that we're supposed to be delivering when you deliver infrastructure as a service. And it's really not much more difficult than that. Literally all the way to click on the little view box there and open up the console proxy to access your VM. So this is what we're heading towards, but getting there is probably a little more difficult than people would like. If you think about the kind of the effort curve of what it takes to build one of these things, Amazon when they started and some of the early pioneers in this industry like a GoGrid or a Joyan or people, they had 50, 60 engineers doing a ton of work to build these infrastructure clouds. And today, most companies that deploy this, there's one or two guys who are responsible for the infrastructure. So the effort has changed, but it's still a pretty sizable effort. You want to know the reason you're doing this. You need to have a pretty good idea, and you should also have a pretty clear idea of what you're getting out of it and what a cloud really is. So I always like to kind of talk through this cloud because so often, if you go out there in the market and you just I'm looking for cloud services, you're going to find everything under the sun being marketed as cloud services. But I always try to at least set up some base definition of what does it take to qualify as an infrastructure as a service provider. And there's a couple basic things. I mean, the first one is you've got to automate the management of infrastructure. Anybody who tells you can sign up for your cloud and we'll call you next week when it's ready is probably not really a cloud provider. And that you want to have instant access to resources so that you can take advantages of all these new cool functions that RightScale and others offer to scale up, right? It's got to be on demand. You can provision not just a VM, but the disk, the storage, the networking. You've got to be able to configure your environment. You've got to be able to add a couple more servers and change some firewall settings, expose the application out to the internet. So basic functional things. Minimum, you have to be able to kind of do these things. And there's a lot more you might see on top of that. This is kind of the minimum set. to me, and this may be a little bit debated, but to me, if you're building a cloud and you can't access it programmatically, it's not really a cloud. I mean, it's probably some web automation that's going back there and kicking off a process to create a VM something. I mean, the whole point and what really Amazon changed was the fact that you can now expect to talk to your infrastructure programmatically and automatically start to make changes, to open up new ports, to modify your firewall and load balancer settings, and to add another couple servers. So API access is key, and it's got to be part of your strategy if you're offering these services as part of a private cloud. If you're thinking about your private cloud, you don't want to force people to go through a UI and go through this. I mean, it's great to have those things, and for a big chunk of your users, that's what they'll use. But for your advanced users, anyone else, the infrastructure's got to be on demand. It's got to be able to be scripted and talk to you like any other system. One of the kind of smartest things I think Amazon did, I've always really admired this, was when they built EC2, they took an approach of offering a really, really basic SLA. I mean, the SLA said, effectively, we'll give you a 99.9% guarantee that the service will be available. But in the fine print, it said at least one data center will be available. I mean, that's a pretty low SLA. Basically, at any given time, you might lose half of the infrastructure, and I've still met my SLA. But you know what? What's so great about that is it kind of tells you, this isn't colo, right? This isn't somewhere where I'm going to tell you it's 100% availability, and then I'm going to write you a check if I accidentally mix. It's basically saying, let's call a spade a spade. This is infrastructure goes down. Data centers are sometimes not available. If you're writing an application to run on Amazon, you better be thinking about multi-site. You better be writing your application to take advantage of the fact that we have availability zones in different places. And this is the one thing that people don't do. I mean, I have to say, even today, when we go out, I'm constantly calling people that I know that are running CloudStack and bugging them to add more sites, to extend beyond a simple, 5 cluster, environment that they're running in their lab, to build some scale, because, the cloud isn't magic. This is no more scalable than the stuff we've been doing in the past. I mean, I had a customer one time who built a cloud, and it was a 4-server VMware cluster running CloudStack on top of it. And the VMware cluster, had a problem, and it went down. And he was like, "Well, why is my cloud not available?" I said, "You don't have a cloud. You have a cluster. You still have a single cluster. It's a single point of failure. You have to realize there's no magic in cloud. Cloud is about distributing workloads so that they can handle failure of individual nodes. They can handle failure of a single compute node. They can handle failure of a switch or a storage array, and they can even handle failure of a whole data center. And if your cloud can't span beyond a data center, you can't start to get some redundancy, you're probably still, leaving yourself. You're certainly not taking advantage of what this is all about and what this means for you. And then finally, the cloud has to be multi-tenant. I mean, at the end of the day, if you just set this up for a single workload and you can't isolate these things, you're probably not accomplishing what the purpose of this is. So these are my kind of hit list for what are we talking about? How do we know when you actually are dealing with something that has the potential to really change the way you deliver IT to your organization? And once you decide that you're going to do this, whether you're building a public or a private cloud, there's some basic architectural questions that every customer goes through and tries to decide. And the first one is, I say this every time and people kind of miss it, but you have to define the target use cases. These clouds are so different. I mean, you got to imagine, when I talk about customers as different as, NATO and GoDaddy, that the requirements that they're going to put on their private cloud are just not the same. They have different security requirements, different user requirements, different expectations of performance for the applications, different types of workloads that they're going to be dropping in there. So you've got to define the target use cases. You've got to understand who your customers are. And that doesn't mean that they can't be relatively broad. I mean, Amazon serves a big, broad use case. But you got to know you're going after that broad use case in order to build in the right kind of functionality and features that will support a broad use case. So define the target customers, understand their requirements, because those requirements then are going to funnel into your technical requirements. So the feature requirements will be based on the use cases you set up. And once you define those use cases, it will be very obvious what features. And we're going to spend a little time on each of these as we go through building a cloud. But once you've finally gotten that required functionality in place and you know what you need, then you can define the technical architecture. I mean, don't start by saying, I want to build a cloud and I want to put it on Zen. It's not the right way to go about this stuff. Understand the features that the customer is going to need, understand how important different things are in that architecture, and then define the technical architecture. And it'll be much easier, it'll be much more successful. And finally, after that, for all of my talk that this isn't easy and you really do want to spend some time, the actual execution of this is not that hard. You can develop and deploy a test cloud in your data center or in one of the companies out there that will host these for you in a week and a half to 2 weeks. I mean, it's not a daunting thing to take on. People do it in a day. So, don't get too discouraged when I tell you it's difficult, because it is difficult. You have to think through the implications. You're doing a lot of automation here, but it's also very achievable. So go in there, do it, and get people's feedback, and then go define the actual deployment you want to deploy. So start with just a little bit on the end user use cases. I always think this is the hardest one to talk about in a presentation because they're just such a varied, set of requirements. But, as you kind of think through what are you expecting this cloud to do, they're probably going to combine a number of these different use cases. But the big ones to think about is who are the users? If you're building a public cloud, are you targeting small, medium businesses for this? Are you targeting traditional people that were buying, web hosting? Or are you targeting, big Web 2.0 companies with 10,000 servers? You're going to have different requirements, and you're going to want to have different levels of complexity and stuff. So if when you think about what this cloud is supposed to do, whether it's application delivery or you're going to be offering sort of small, medium business IT services, think about that customer's use case. Put your foot, kind of sit down in the customer's experience and think about, try not to overcomplicate it. This is the one thing that, the reason that a lot of companies struggle with delivering cloud services to, to kind of SMBs is they make this stuff too complicated. They expose an API, or, anyone who worked on Amazon, 4 or 5 years ago knows that you weren't going to use that if you didn't have a reasonable level of technical chops. And so, what we're seeing today is that companies who are focusing on that market are making these things simple. And, I can probably show you guys a little bit of what GoDaddy has done with their cloud, but they're, they call virtual data centers, and these are, very easy to deploy, very single click to deploy an application that's load balanced in 3 or 4 servers. And it's that level of simplicity sometimes that's the key to making a successful service offering. At the same time, if you're selling, if your customer, whether it's internal or a paying customer, is as a developer, give them the tools, give them lots of flexibility, make this as usable as possible. And similarly, if you're going to be doing certain use cases, you're going to define feature requirements that are quite different. And I always try to bunch these things together. This is not an exhaustive list. It's a huge mess of text that I think this presentation is available, but. Basically, try to bundle your requirements for this infrastructure as a service into some basic categories around things like, what you expect from the virtual machine, what you need the networking to do, what you need the storage to do, how, what kind of, specific functions you need out of this system. Do you need features from the virtual machine level like, Windows support? If so, you probably don't want to run a big KVM cloud if you're going to run a ton of Windows. You can do it, but the performance is nowhere near as good as if you run it on VMware and Xen. Right? So if Windows is a big part of your business, that might impact what you decide to use as the hypervisor. If you need to have things like really tiered different types of IOPS and kind of very easily tuned storage performance, you're going to want to look at different storage vendors and probably different hypervisors that can allow different things. From a template perspective, if you want to give people the ability to upload any kind of template and then convert it into the type of infrastructure you're running, that's going to require some features that may not be base or standard in the system. So kind of go through these things. Do you want to use ephemeral disks like Amazon uses, or does everything need to be persistent storage? What kind of high availability are you going to offer? Is it just if a VM goes down, I'm going to kick off another one? Or does it need to be pairs of VMs running in memory synchronization that you can really only do if you pick VMware as your hypervisor? From a networking perspective, what kind of SLAs and what kind of QoS can you offer to the customers? How important is that? If I'm going to be running, if I'm trying to target the enterprise and they're going to be running database-driven applications, I need to be thinking about the quality of service that I can offer from a networking perspective. If I'm working on a different level, that may not be important, right? So I've got to kind of go through each one of these things, understand these individual functional components, and this is this is non-trivial. This is the product manager's job, sort of, if you're building a public cloud. And in a private cloud, this is where you need to spend some time with the users, with the people that are going to be developing on it, that are going to be, what have they experienced that they've liked, they've not liked. And by all means, go play with some of the public clouds. I mean, the great thing about 10 cents an hour is, you can get your credit card out and go try 10 of these things, experience what they do well, what they do poorly, and come back with ideas on what you want to do in your own private cloud. And that will kind of help you decide, what the user experience needs to be like, what some of the, operational things you might want to do. I mean, how important is live migration of VMs, right? If you want to do a lot of live migration, you might pick one hypervisor over another. You pick a different networking model or storage model. How much bandwidth they're going to use, though, constantly moving around VMs to optimize your load, that eats up a lot of bandwidth. That's going to reduce your, it's going to certainly mean you better put in 10 gigabit networks and maybe multiple pairs of these things. So picking the right network architecture becomes very difficult. Picking the right storage architecture becomes difficult if you don't know what the use cases are going to be doing. And unfortunately, when you skip this step, you make decisions based a lot of times on, kind of basic business models where you say, okay, I know we need to get to this, this kind of a cost per VM, so let's pick this storage vendor because they're less expensive, and we'll use this networking because we already happen to have some and stuff. And then 2 months later, you're pulling stuff out because the performance isn't good enough, or you've got, worst of all, you've got unreliable equipment. I mean, one of our providers that built a very big-sized cloud, they chose to use a switching fabric from, a vendor that wasn't probably well known for their switching infrastructure, and it caused them a lot of problems to the point of outages that were impacting customers because their networking wasn't reliable. They would lose entire segments of the network. So understand what you're trying to do and decide what you're solving for. If reliability is key and reliability is number one, then for all of our talk about how the cloud allows us to use commodity infrastructure, make sure you're using infrastructure from vendors that you have confidence in, that you believe will be reliable. Because while the cloud can certainly handle failures and it can handle lots of failures, those failures still have big costs to you. They cause lots of tickets. They cause you running around trying to fix problems. And you're going to have plenty of users who don't architect their applications to deal with failure. And so that unfortunately means that even though they could have used the fact that there were 3 availability zones and spread their workload around, they chose not to, and they're now calling and screaming because you've had an outage and it's caused their VM to go down. So all these things can be resolved. There's ways to basically deliver every level of this stuff, but you've got to think it through. You've got to understand what type of experience that customer is going to want, and it gets pretty specific. So once you've got this, you understand what you do. There are sort of some big key elements that are kind of the big choices you've got to make, and they're not surprisingly start with the hypervisor. Every cloud you're going to talk about is going to be provisioning to a virtual machine nowadays. And while there are clouds now that provision to bare metal, and so you could even say we don't want a hypervisor, we simply want to provision an image, the vast majority are going to be running on one or more hypervisor. And here, the good news is I think I've been, now this is my 3rd or 4th RightScale event. And I think the first time I got up and gave a presentation, I talked, and I think I gave an analogy. I said, well, when you're picking a hypervisor, it's like buying a car. You could, used to be that you could buy a Toyota, which was VMware, and you could buy a bike, which was Zen, and you could walk, which was KVM. And if you wanted to use ESX, you would probably just walk backwards and then you'd get there. So this is about 2 years ago, and the good news is all of these have matured and moved forward. And I think it's probably to the point now where if I take that same analogy, VMware has become a Lexus. There are, it's certainly the most expensive option, but it gives you a ton of very interesting and useful features that can make a lot of sense and make good sense if you've already have an enterprise license to run on VMware and should be considered. But Zen and KVM have both matured a lot. I think Zen is probably at the point now where it's running about 60 to 70% of all of the hosted VMs out there, given that it's used by so many of the large cloud providers. It's probably become the Toyota. It does all the basic stuff you need it to do reliably and reliably well. KVM is not far behind. It's grown up very quickly and has added a lot with a few exceptions. The big thing is probably if you're going to be doing a lot of Windows, you still should be inclined to go with something besides KVM, just because the support for para-virtualization and a few other things is probably not quite as good. But even on that, I think it's getting a lot better. And if you go with the Red Hat versions of KVM, you're going to find it's quite good with Red Hat SICK as well. So you have a lot of good options here, different price points, different feature sets. A big part of this, though, I would say, is make sure you have somebody on staff who knows this hypervisor cold, because the hypervisor is still going to be a core piece. It's going to have a lot of impact on your availability and the features you're delivering, and you're going to want to make sure you have somebody who knows that hypervisor layer well, because all of these cloud infrastructure really, if it's done right, it's going to tap into that hypervisor and it's going to exercise the heck out of it, because it's, these hypervisors have a lot of functionality now. Once you've kind of made that decision, you've picked the hypervisor that meets your requirements, or potentially pick 2 or 3 of these. There's clouds now, including CloudStack, where you can run multiple hypervisors in the same environment and simply let the customer choose. But still pick the hypervisor that you think is going to be dominant and make sure you're staffed up well to use that. The next hard part is picking a networking model, and this is this is not getting any easier. To the contrary, it's getting more difficult. There's more good options happening, because at the end of the day, the hardest part of building a cloud is getting the networking right. And from a user perspective, provisioning a VM isn't that complex. I get a VM, I can upload my image, I can start using it. But making sure that VM can talk correctly to the different infrastructure pieces I have is hard. And there's basically 3 types of networking architectures you can choose to implement when you're building an infrastructure cloud. The first and most common is the kind of traditional enterprise networking approach. It's a VLAN-based approach. And basically it means I'm going to take and use VLANs to do network isolation. I'm going to give every customer in the environment at least one VLAN. They're going to sit on that VLAN, and all of their VMs will sit on that VLAN or a couple more VLANs. But they'll be segregated from all the other users in this cloud using pretty traditional networking models. The good thing about that approach is all of that network infrastructure you've invested in the past, the firewalls and load balancers, the MPLS connectivity, and all of the infrastructure you've already got is going to work really well with this. So it works really well in the existing infrastructure you've got. So if you're building a private cloud, this is going to be the way that you can easily come in and not freak out your networking guys and tell them that you're doing something wildly different. If, on the other hand, you want to do something wildly different, the Amazon approach to networking is really cool, and it's very different from this approach. And what makes it better in some ways is its scalability. So the Amazon approach is what we call flat networking, but basically it means that instead of trying to use VLANs, which are great for isolation, but are limited in the sense of you can only put about 4,000 of them on a single switching fabric, and they have some spanning tree issues and other things. So if you want to go into a flat network, you're basically putting all the VMs out there on the same big network, and generally allocating them a public IP address or a private IP address if it's in your own network. What's great about this, though, is that the isolation is being done now at the hypervisor. So at the hypervisor, you're basically running a little firewall, an IP tables, open source firewall inside the hypervisor's DOM0. And that's what you're doing when you program things like security groups in Amazon. You say, okay, these 6 VMs can all talk to each other, but and they can only talk over this port to the VMs in this other group over here. And it works great. Isolation is achieved. The challenge is that you might find, when you go in to talk to your security architects, they're a little less comfortable with this than they are with, this is running behind Cisco, this is running behind my Juniper SRX, this is running with my existing network architecture, and I've attached it to the VLANs you're all familiar with. So different models. Where this flat network, though, really comes in handy is when you start to scale. If you're going to be scaling to the 5,000, 10,000, 20,000 server levels, and you're building a cloud to run some really big web services or to run huge computation farms, things like that, the advantage of the flat network starts to become very much worth considering. But it's becoming much more popular. We're seeing it all the time. The other questions about the networking are a little more mundane. I mean, how much capacity do you need? Do you need gigabit? Do you need 10G? What type of, where does the guest traffic go? Where does the management traffic go? What type of network in there? It's, it's usually pretty well spelled out based on what you choose from a networking model approach. I said there were 3. I've only really talked about 2. There's a third type of networking, which is, really exciting, and it sort of seems to be where the future's coming, and that's what companies like Nicira are doing, where they're doing sort of virtualized networks that are not using VLANs, but rather doing packet encapsulation and creating dynamic VLANs at the hypervisor level as well, but with a slightly different approach than the flat network. So that stuff is still a little bit of Open vSwitch and some of the work that's going on there is still a little bit out and a little further out in terms of mainstream adoption, but it potentially solves all the same problems that the flat network solves, but makes it so I can still integrate with all that existing network infrastructure that I've paid for and my security guys like a lot. So potentially a solution that's really going to solve this is that area. But the last sort of big chunk of your network and infrastructure you've got to define is what kind of storage platform you're going to choose. And generally in the cloud, there's two big pieces of storage that you need to have. One is your block storage. It's what's going to run all those VM disks, and it's where you're going to run the C drives and the D drives and the E drives of your virtual machines. And the other is your object storage, or your kind of secondary storage. And this is your S3-like storage. It's simply a get, put, post type object store where you can put images and files and then call to them whenever you need them. And both are important, and both are generally part of any deployment, because the great thing about the object store is they allow you to start doing things in some of the more interesting models that you just can't do with just block storage, in terms of getting images and files and things like that can be pulled from lots of different places and pulled into your applications. But the block storage is much harder. I mean, the object storage is relatively straightforward. There's a number of good options out there, whether it's tools from vendors like NetApp or EMC. EMC's Atmos is a good version of object store, or open source projects like Ceph and Gluster and Swift. They all offer quite a few good object stores, and you should be able to pick any one of these. And we have plenty of customers who just use basic NetApp NFS based object stores today. So there's lots of options for that. Block storage makes a much bigger impact on your user's experience in the cloud. So picking the right type of block storage or the right choices for the user to pick from block storage are really is much more important as the cloud architect, as you're trying to figure out what to put here. And it's pretty similar to Amazon in the sense of what your choices are. They really come from, do you want to build your cloud using local disk and use all that local disk that's running on those VMs? In which case you're going to get great IOPS performance. You're going to get really low cost for actually running these things. But you're going to get also you're probably not going to be doing a lot of live migration. Things like HA aren't going to work very well if you're all on local disk. Or you're going to want to do to more of a shared SAN type of storage, whether it's iSCSI or NFS or Fiber Channel. And in which case there the price goes up. You start to get into needing more operational managers. You need people that actually know how to run a SAN. But you're going to get a lot of benefits from a customer. And most people today are going with not a local disk-based storage model. I mean, they may be using local disk for certain workloads, and so they'll make it available to some customers. But again, I'd kind of go back to your first point. Know what your customers want. Understand what the use cases are. If you're going to need a lot of IOPS, and if you need, people don't care about storing any perpetual data or need HA or anything like that, then local disk's great. I mean, some of the biggest clouds we're working on are all using local disk. But if you're using this for more of a traditional IT function, you're going to want to make sure you can give people some persistent disk access, some good SAN-based storage. And here there's great vendors to work with, really, from the open source world, like I mentioned Gluster. Gluster does a great job with this. ZFS is a good option. Nexenta does a great job of delivering a storage platform that works really well and scales really well for service providers. There's then obviously there's the traditional and probably the most popular for us. We see NetApp constantly being used for cloud storage for people who are worried about availability, want to get something good, but still get a reasonable price point. EMC, Hitachi, and others do a great job of delivering fiber channel stuff. There's some interesting companies out there, though. I was in a meeting just the other day with a company called SolidFire that does a really nice storage platform. It's all SSD, but it does IOPS guarantees on VM. So again, knowing what your customers want, there's great tools out there, and as long as they're exposing an iSCSI or an FS or fiber channel type of hook, it should be very easy to get it to work with your infrastructure structure. So look at the different storage options, look at the price points, look at the performance requirements, and pick the right vendors. But these are areas both on the networking and the storage area where the wrong choices here, if you don't know your requirements, can come back to haunt you. You can invest a lot of money buying something that's overkill for what you need and really skews the cost that you're going to have to charge somebody for delivering the service, whether it's internal or external. So, once you've made all those decisions, you're ready to start deploying. The real question is where. We see kind of the whole range these days, and this is pretty common. We see people who want to deploy. Probably the majority of private clouds that are built are deployed on premise today. They're kind of, a lot of them start as skunkworks types projects. They come out of, developers and all sorts of places. But they'll get set up in a lab. They'll get set up sometimes even under somebody's desk. But most of these, most people who make a decision they want to deploy an enterprise private cloud are going to build in their data center. But we're seeing, more and more people who, are finding that the complexity of this makes it difficult, and they actually are going to service providers. Datapipe is a great example of one. SoftLayer is a good example of one, where the provider will deploy an entire pre-configured cloud for you in a matter of hours that meets your specs, kind of understand. This is not a shared public cloud. This is not a white label of what they're offering to everybody. This is you've got 10 servers. That we want 10 servers. Okay, put 10 servers up. Set up the management layer. Pick between some networking models. Pick between the storage models. So you can actually get clouds on demand as opposed to accessing cloud. So you can build your own cloud. You can have somebody deploy it for you. You can have it managed on site, or you can have it managed at the provider's location. And then obviously you can start getting into accessing the public clouds that are provided to you. And here there is quite a range in terms of the amount of control that you're given. I mean, it can be as Amazon-y as, here, just give me your credit card and you'll be on all shared infrastructure. But there's a lot of people who will offer, public clouds that offer dedicated storage, dedicated compute, and actually quite isolated, even if you might be sharing the network bandwidth or sharing the network backbone, I should say. So there's quite a range of different types of places that you can deploy to still deploy a private cloud. Then it's just a matter of scale. And as I was saying before, the key to scale with CloudStack and anything else is figuring out how much infrastructure you're going to run. Do you start with a single pod, one or two clusters in that pod, and then scale out? And really, most of these products are going to be architected to take advantage of availability zones. So you're going to want to say, am I just running this in one data center? Is it one availability zone, and all of the users who consume this are going to push it into that availability zone? Or am I going to run, a management server cluster that supports multiple data availability zones around the cloud? And this, if it's not obvious, this is what I highly recommend you do. I don't think you can really deliver the benefits of a cloud until you start to break free of a single data center umbilical cord. One of the neat things, though, is that these availability zones don't have to be broadly public. They don't have to be everyone can see every data center. You see, some people are going to deploy 3 or 4 data centers that are available to everyone, and then set up maybe certain data centers. I mean, we have customers who have certain development teams that have a private zone that only they have access to. No one else can see it. It's we have ultra secure whatever that makes us think that having these dedicated servers will be better. So you can choose to have private or public availability zones, and that's really hopefully gives you a basis for understanding how to deploy one of these things. It's not that much more complicated than that. You need to know what the customers want to do. You have to understand the features you're going to offer to them, and then build up the architecture from the network, the storage, the compute, and the hypervisor choice you're going to deploy on. So I won't spend too much more time. I've only got a couple more minutes, and I get a feeling there might be some questions. So I hope that helps. I'm happy to answer questions. There's a little CloudStack booth over here, and as well as down on the floor. So you can always come by, get a demo, see what this stuff actually looks like. But hopefully this gives you some idea on how to deploy and build a CloudStack implementation.